Hello everyone, I am Sujata Mohuril. Welcome you all in the video lecture on the topic inverse Z transform by partial fraction method. Z transform of the sequence f of n is defined as Z transform of f of n equal to summation n equal to minus infinity to infinity f of n z to the power minus n, its value equal to capital F of Z, where Z is the Z transform operator. Now inverse Z transform, it is denoted by Z inverse, and its value Z inverse of capital F of Z is given by f of n. Now for example, Z transform of 1 and Z transform of u of n have same value z upon z minus of 1. If we find out its inverse, z inverse of z upon z minus 1, then it has 1 or u of n value. In this way, we can write down all formulas and properties of z transform in terms of z inverse. Now, but whenever we are finding z inverse z transform of the capital F of Z function, then there are four methods: partial fraction method, convolution theorem, residue method, and power series method. In this video, we are going to discuss this partial fraction method. Partial fraction, here, find the inverse Z transform of this by using partial fraction method. For this, we consider the capital F of Z value, that means this value, f of Z equal to z minus 4 upon z minus 1 z minus 2 whole square. Now for partial fraction method, here a upon z minus 1, this is the linear term. Then b, here repeated values z minus 2 and plus c upon z minus 2 whole square. Now by applying partial fraction method, that means we're taking LCM here and then simplify the terms. In the numerator, this denominator term cancel with this. Therefore, the numerator term z minus 4 and right hand side a into this value z minus 2 whole square and so on. Then open the bracket, simplify the terms, and then combine the terms of z square, z and constant term. On equating the coefficient of z square, z and constant term, then we get these three equations. We solve these equations by any method and find out the values of a, b, c. Now here, from first equation, a value equal to minus of b, we substituting these values in this second and third equation, reduces these two equations in terms of b and c, and we solve these equations and find out the value of b and c, and then we substitute this value in a, therefore we get the values a equal to minus 3, b equal to 3, and c equal to minus 2. Now we substitute these values in the equation and find out z inverse of this value. Therefore, z inverse of minus 3, this is the constant value, upon z minus of 1. Now, z inverse of 1 upon z minus 1, its value equal to 1 to the power n minus 1 u of n minus 1 by using this formula. Now, same formula we use for second term, value of a equal to 2 here. Therefore, 3a is constant term, 2 to the power n minus 1 u of n minus 1 term is there. Then minus of 2 here, which is taking outside in last term, and here apply next formula, z inverse of 1 upon z minus of a is a whole square, its value equal to this. We substitute this here and value of a equal to 2. In this way, we solve the equation, that means f of z value, and find out the value of f of n. This is the first type. Here we directly consider f of z value and simplify the term. Now second equation as second example, find inverse z transform of this term by partial fraction method. Now here we consider the given function as f of z. Now in this example here we can take this z common from the numerator. If it is possible, then we have to take z common from the numerator and write down the value of f of z upon z. And remaining term we solve by partial fraction method. and use equation number 1. Therefore, we consider this value solved by partial fraction method. Therefore, a upon z minus 1 and bz plus c, because here quadratic term z to the power 2, therefore bz plus c we consider here. And then again solve by taking LCM, denominator term get cancelled, open the bracket, simplify the terms, combine the terms of z square, z and constant term, and then after equating we get these three equations. We solve these three equations and find out the values of a, b, c. Here a equal to 1, b equal to minus 1 and c equal to 0. Now we substitute these values in equation 2 and then again shifted this z on right hand side, therefore z upon z minus 1 and here z square upon z square plus 1, and taking z inverse of this term, then we get the value of f of n. This is the value of fn. Here z inverse of z upon z minus 1, its value is 1, and z inverse of z square upon z square plus 1, its value is cos n pi by 2. This is the another formula, z inverse of z upon z square plus 1 is sin n pi by 2. Whenever we require, we substitute these values. Now, third type is this. In example 3, find inverse Z transform of this by partial fraction method. Now here, uh, if we consider the value of f of z, here degree of numerator is 2 and degree of denominator is 2. Whenever the degree of numerator is same as degree of denominator, we cannot apply directly partial fraction method. In that case, we divide the terms. Here, this is the numerator value, this is the denominator value. Apply this, this is the quotient 3, and remainder is 11z minus 5. Therefore, we write down this capital F of z value as 3 plus 11z minus 5 upon denominator term. Now, we consider only this value for the partial fraction. And lastly, uh, find out a and b values and substitute here in this equation, and then substitute all these values in equation 1 and find out z inverse. Therefore, here values of a and b are minus 6 and 17. Because linear equations are there, we easily find out its values by substituting z equal to 1 and z equal to 2. Now here, when we taking z inverse of these 3, then z inverse of 3 we can write down is this as delta of n. Then 6 into z inverse of 1 upon z minus of 1, its value equal to 1 to the power n minus 1 u of n minus 1, and 17, this is the constant value. Z inverse of 1 upon z minus 2, we can write down this as 2 to the power n minus 1 u of n minus 1. In this way, we solve the three types of partial fraction method problems. These are the practice problems. Thank you.